Hello and welcome to Mobility Global's Autology podcast series, where we bring together industry experts to explore the trends reshaping the automotive industry and what they mean for manufacturers, suppliers, and the wider mobility ecosystem. Today we're looking at one of the biggest forces shaping the automotive industry, China speed. It's the ability of Chinese companies to move from idea to product, scale production, and respond to changing customer needs, often much faster than their Western counterparts. Chinese OEMs have dramatically shortened their vehicle development times, accelerated innovation, and become more responsive across engineering, software, and supply chain. But is their advantage simply about engineering capability and speed, or is something deeper at play, a different way of using data, AI, and collaboration to make decisions, learn, and adapt faster? Joining me today are three experts who each bring a different perspective on what it will take to compete in the era of China speed. First, we have Hanno Focken, Managing Director, Activation, Governance and Operations at Catena-X, a business that is helping the automotive industry build a trusted data ecosystem, enabling companies, suppliers and partners to collaborate more effectively across the value chain. Hi, Hanno. Welcome and thanks very much for joining us.
Thanks, Matthew. Good to be here.
You're most welcome. We're also delighted to welcome Isaac Squires, CEO and founder of Polaron. Polaron uses generative machine learning to accelerate the design and optimization of advanced materials, helping industries such as automotive explore new approaches to materials innovation. Hi, Isaac. Welcome. It's great to have you back with us.
Thanks, Matthew. Great to be here.
You too. And finally, we have Ben Townsend, Head of Automotive at Thatcham Research. Thatcham provides automotive risk intelligence and research, helping manufacturers, insurers, and repair networks improve vehicle safety, security, and repairability as vehicles continue to evolve. Hi, Ben. Thanks very much for joining us.
Hi, Matthew. Really looking forward to it. So it should be good.
Us too. Thank you. It really is great to have you all with us today. You've already shared some really interesting insights on China speed through our recent one-to-one conversations on Auto Tech Insights, and those conversations are now available as Q&As to download on our platform. So in this episode, we want to take the conversation a step further and explore what China speed really means, what that competitive advantage comes from, and how the Western automotive industry can respond. We'll start by looking at the foundations that enable this speed, from data sharing and collaboration to AI-driven innovation and responsible validation. Then we'll open up the discussion and explore what a realistic Western version of China speed could look like over the next 5 years. So let's start with the foundations of how companies work together. Hanno, you've made the case that China speed is really about how quickly companies can share data and make decisions rather than engineering capability alone. How important is trusted data exchange in enabling OEMs and suppliers to collaborate differently? And what needs to happen for that collaboration to translate into faster, better decision making, would you say?
Yeah, let's dive right in. Let me start with the number that frames the whole debate. A new
Yeah.
vehicle program in China typically runs about 2 years. In Europe and North America, it's 4 to 5. When you look for the cause of that gap, the instinct is to look at the engineering capability, but Western engineering isn't 2.5 years slower. The difference isn't what happens inside companies, it's what's happening between them. I spent a lot of time in China recently, and what strikes you on the ground is not that the engineering is exotic, it's the institutional distance, or rather the lack of it. Suppliers sit in tight geographic clusters, often a short drive from the OEM. In some companies, a large part of the stack is made in-house. Production status, quality metrics, and supply commitments are shared in real time as the default, not the exception. And platform-level data sharing carries far less competitive and legal anxiety than it does here. Design changes, quality signals, demand revisions, and compliance requirements travel through digital channels built for cross-company flow, not through emails and PDFs that get rekeyed at every tier. Decisions move faster because the data underpinning them moves faster. The trusted data isn't a layer on top of collaboration, it is the collaboration. And trusted is the important word. Western industry works within real constraints, sharp IP boundaries, competition law, GDPR, data treated as a commercial asset to be guarded. Those constraints are not going away, and they shouldn't be wished away. What Catena-X does is not work around them, but make data exchange possible within them. Competition law, IP protection, and regulatory compliance built into the architecture and governance, not bolted on afterwards. So concretely, that rests on 4 principles for us. Verified digital identities, so you know who you're dealing with. common standards and semantic models so that the same component specification means the same thing to every participant in the chain. And looking at an automotive supply chain, you're dealing with like tens of thousands of companies usually. Data sovereignty, so each company decides what it shares with whom and for what purpose, and neutral governance. So no single player owns the infrastructure, meaning the power dynamic between OEMs, suppliers, and IT outfitters is always balanced. A data space, so what we're calling the basic component of, or the concept of Catena-X, is not a central platform where everyone deposits their data. It is the infrastructure that lets companies exchange data directly on conditions they define and the architecture enforces.
That's
I
great.
know I've been talking for a long time.
That's really useful. Very, very interesting insights there, Hanno. And also, thanks very much. It was interesting for your last Q&A, expanding on those points. Thank you. It's becoming a key enabler of faster engineering, but many organizations are still struggling to move beyond isolated pilot projects, if you like. Isaac, you made an interesting point that the next challenge for AI is moving beyond proving the technology works and embedding it into everyday engineering. What do you think are the key steps automotive companies need to make to move from AI pilots and individual use cases to widespread adoption, do you think?
Well, I think it's an interesting point that I think I see over and over again, that often the barriers that we see are not technical barriers. It's not the technology doesn't work. We've run our fair share of pilots. It's never that you can't prove the value or the benefit or something that actually works and does what you say it's going to do. What's often quite difficult is getting organizations to make changes in the way that they work and in the decisions that they're making across programs and changing the behavior. So the first step, I think, like if we're thinking about a bit of a recipe for success, the first one is to treat AI like we treat engineering programs, not like a showcase of technology, not just purely like a open innovation project that gets a nice kind of presentation after however long.
Yeah.
And that means that this has to be around high value decisions, the kind of upfront defining what success looks like, and then really believing that this is the way we're going to do things going forwards, and then building and shipping and iterating like it's an engineering program, not like it's a one-off. I think that showing improvements in like speed or accuracy or something in isolation, it's interesting, but it matters way less than like actually embedding AI into standard processes, into how like teams design or qualify or validate technology. I think that the second step is kind of touching on what Hanno said, which is that we also have to not just fix the model itself, but also like the interfaces. So we see the biggest delays in the way that actually delivering value to our customers usually sits where you have kind of disconnected data sets or very slow validation loops or people waiting to like approve various decisions. AI becomes more powerful when we can actually turn all of this messy, complex data into measurable signals so that teams can move forward. So I think that part of this kind of wider spread adoption is in fixing these interfaces as well. And then I think the third one, probably the most important point about how to succeed with these and how to drive beyond pilots is, again, maybe something slightly structural rather than like technical, but it's giving ownership and autonomy to the people that are closest to the problem. And this is actually when we're thinking about like the connection to China speed and the way that China is driving forwards AI adoption inside like the automotive sector.
Yeah.
I've seen this like firsthand. Engineers have the appetite and often the skill set, but what they don't get given in the West is the budget and the room to go and take risks. I think that AI is a very disruptive technology, and therefore we need that mindset that it is a risk, that you have to go and you have to fail. And teams need that space to experiment, to learn, and like I said before, to iterate and to treat it like it's an engineering program without worrying about career risk or having all these layers of gatekeeping. You don't want to have to get some project signed off by the CEO when the team is ready to go and ready to use things. So I think if you give capable people real ownership and protect their ability to move on these things, that's the way you can really change the organization.
Thanks very much, Isaac. Very interesting perspectives there. Thank you. We've talked a lot about getting faster, but there's another important side to this discussion. Ben, everyone agrees that the industry needs to accelerate, but from your perspective, where does speed genuinely add value, and where do manufacturers need to maintain discipline because safety, repairability, and proper validation remain essential?
So I think when it comes to value, the reality with speed is what speed does is it creates different market conditions, and different market conditions can lead to better consumer outcomes. So when we're talking about speed and value, the value proposition there is better consumer outcomes. The flip side to that is that engineering discipline, and we've heard both Hanno and Isaac talking about how we can use that engineering discipline differently, but how do you ensure that speed doesn't get in the way of that engineering discipline and therefore create worsening consumer outcomes? So again, it's that focus on what is it we're trying to achieve and what is that output. The speed should be creating better consumer outcomes. The lack of discipline can counter that. I think certainly from what I've seen, particularly with the Chinese manufacturers, speed and discipline are not opposing forces. So what we are seeing with the Chinese manufacturers is they are implementing a different way of doing business. They're not tied up with legacy. They're not tied up with all of the kind of baggage that some of the Western engineering companies and the processes have come with. So they are approaching it with a very different viewpoint, and they're building speed and discipline into their processes. And what you see with that is that greater consumer outcome. I mean, I don't know if you've had the opportunity to visit some of the auto shows in China, but you see massive amounts of consumer choice, be that technology choice, be that platform choice, be that software choice. All of that is coming with that speed. The message that we're really driving into the marketplace with the work that we do here at Thatcham Research is to focus on the right bits for discipline. So you spoke about repairability. Repairability, safety, security are critical parts of that development process. Ensuring that we use the right data and we focus on the right ways of using that data within those processes to ensure we don't throw the discipline out. But for me, the key is the consumer outcome. If you focus on market conditions and you focus on consumer outcome and you use the right data at the right points of your process, there's no reason why speed can't bring huge value.
That's great. Thanks very much indeed, Ben. Now, I'd like to thank you all for your points there. Most interesting. I'd like to open it up, if I may, for more of a panel discussion. We've heard about data, AI, and validation. Looking across the industry, what would you say is the biggest organizational or structural barrier preventing Western OEMs from increasing their pace of innovation? Who'd like to go first? The floor is yours.
I'm happy to jump in if.
Yes, please do.
So I think one of the things that I've really noticed is holding some of the traditional manufacturers back is really that focus on hierarchy within the way they do business, and the way those organized structures restrict, particularly looking back at Hanno's first question, the way in which the data flows through an organization. If you're constantly having to look up and then come back down and cascade up and cascade down, that brings a huge amount of delay into the process. And then the point that Isaac made there is who should own this. Actually, if we can switch these organizations into understanding where that data and where those decisions actually need to be owned, only using the hierarchy and the cascade where you need to. And this is something that the Chinese organizations do really well. I think the biggest takeaway for me is I'm not seeing a lack of capability across any OEM that I go to see. The capability is there. It's connecting those capabilities together. And how do those organizations connect those capabilities at the right levels so that they can learn and respond much more quickly?
I think it flows quite nicely because, Ben, what you mentioned about is like let's say the boundaries within the individual company and how a hierarchy and let's say data flow within the company plays into it. I would argue it goes a little bit beyond that in how Western OEMs are organized, largely focusing at themselves as enterprises, but they now have to compete with, if you're looking at China, more companies that are organized as ecosystems. So everything in the Western model, the IT landscape, the contracts, the incentives, the internal KPIs, they're all optimized for the boundary of the individual company. And I think there's only so much you can optimize there, right? Each of these boundaries has a data toll booth on it. An engineering change has to propagate through hundreds of thousands of suppliers, not just within the individual company, each running different systems and formats. quality and compliance data gets rebuilt from scratch for every customer and every market. And I know personally that the suppliers are really fed up with that to a certain degree, and they're asking for standardization of it. And none of these are engineering problems, to echo what Isaac said before, right? They are coordination problems with engineering consequences, and they carry a hard cost for a supplier with billions of euros in revenue, right? If you're looking at the tier one supplier, manual compliance reporting can climb towards 2% of revenue. That's 20 million a year. And obligations are expanding, specifically like if you're doing business in Europe. And if every single OEM is interpreting these requirements differently and are asking for different, let's say, data requirements from their suppliers, that can like explode into just a cost component, right? And underneath that, it's a cultural barrier. Data is treated as an asset to be defended, like also taking on the cybersecurity argument, rather than one that gains value when it moves. Like if you're looking at AI, I think we're seeing a little bit of a shift there, but still, if we're looking at the, let's say, engineers that have been building their careers inside these companies for 20 years, it's hard to change that mindset, right? And some of that caution is legally justified. Much of it is habit, however, dressed up as risk management, I would say.
Yeah, I think very quickly on that, I think exactly what Hanno just said, that the kind of barriers are all kind of formed from in kind of misaligned incentives from, like he was saying, the kind of structure of the enterprises all the way down to like the structure of the organization and the teams and the way that, you know, engineering is actually done. That the incentives that we have today still favor kind of caution over learning speed. And that's because of these like legacy frameworks that these companies kind of built around, which the Chinese automotive manufacturers have been able to build something new. And I think fixing the incentives all the way through the different length scales of the company is really that's where the change actually has to happen.
Yeah, thank you very much indeed. Really, really interesting discussion. Just looking beyond technology, what changes do automotive organizations need to make in their culture, processes, and decision making to turn those capabilities into a genuine competitive advantage?
It's about creating the right incentives. So if I maybe start from looking at like an engineering team in itself, how do you create the incentives for that team to move fast, to adopt new technology, to take risks? I think that it means like investing early in these technologies and really culturally creating this space for teams to fail productively. And I think we've seen some good success stories of this where teams have open innovation teams at large corporates have created specific budgets and created kind of like internal programs to be able to test new technologies. But that often then gets stuck in what we were talking about before, which is that you end up just doing pilots and then and never moving forward. So I think you have to be able to reward people for taking those risks, but also now start to think more about how do we ensure that we embed those changes in the way that work is actually being done in these companies and not just one-off programs. I think we've solved we know how to test a new piece of technology, but we haven't solved how do we turn that into embedding that into a new kind of like pattern of work.
I think one thing I would add to that, and we kind of touched on it in the last question, is that difference between engineering discipline and habit. And I think if we go back into history and look at what's caused, I'm going to use the British car industry as an example, what's caused the British car industry really to fail, it was because we relied on habit. We relied on what we have always done to get us through. And the reality is habit is not engineering discipline. You know, as an engineer, a 20+ year engineer, to me, engineering is about understanding a problem and looking for a solution. And you don't do that with habit. You do that by challenging yourself. You do that by learning fast. You do that by trying different things. The fail fast, learn fast to me is something that's been nailed into the way I always look. Then there has to be that cultural change within OEMs that we need to understand that failing is not failing. Failing is okay. Failing is part of engineering discipline. Habit is failing. That is a huge cultural shift. And I think the biggest advantage that any organization is going to take is how quickly they can learn, how quickly they can respond to that changing marketplace. Because if we don't respond in the West, we will be the British Leylands of the future. It is that binary to me.
I would agree and disagree at the same time. So I like the point, the wording that Isaac used in terms of like stop treating it as pilots. But even if you don't treat it as pilots, let's say a lot of the requirements that are hitting an OEM and large suppliers at the moment can be seen as individual requirements, right? Like a new requirement from a new regulation in Europe here, a new requirement in terms of let's say increased quality management systems there, and so on and so forth. And if you go by that logic and like basically then taking up your point, you release and iterate, right? You implement and then you learn from it, and then you, let's say, go to the next iteration. It will still amount to, in the end, from an architecture perspective, like for data management, in like 100 different systems. And this is what's the, let's say, a little bit of a shift in, I believe, some of the OEMs that we're working with, like one of the largest ones has recently had let's say, a board meeting on that subject. And in the end, positioned a data ecosystem like Catena, not like, let's say, a concrete project with an ROI attached to it, but rather like the means to survive over the next 2 to 3 years, like on all the different requirements related to data that are heading our way. And you just have to look at the regulation. It's insane, like what's happening until 2030 to go into that direction. So I would say not just, let's say, building for, like, let's say, a very effective way to solve a problem, but you have to set yourself up as a company in a fundamentally different way to manage like those amounts of data, not within your company, but like taking into account like the responsibility, accountability you have to take across your supplier landscape, the different requirements and the synergies you can, let's say, create between them, and how fast you can have it accessible and be able to act on it in the end. So those I would add to the mix in the end, and that requires foresight, not reaction alone.
Can I come back on that? I think
Yes.
that's a really interesting point. And you know, I think what you've tapped into there is that, like, I think the way that these companies have thought about software before is as tooling. You know, as like we're gonna buy a piece of software to solve this specific problem on this part of the value chain of the thing that we're trying to do in this part of engineering or this part of procurement, whatever it is. I think what you've said there is exactly correct, which is that, like, you have to start thinking about data and AI as a long-term, like, strategic priority that fundamentally is changing the, like, infrastructure and the fabric of the way the company works. And that is not something that you can trial some new piece of technology for, you know, 3 months to figure out. It's something that has to be built into the way you make decisions about the way you're building and growing the company. And I think it's a very good point.
And lastly, and hopefully Matthew and Ben, you won't, like, just one last sentence to that. Contradictory to that is the current economic landscape in the automotive sector, right? No one has money to invest is the issue. So you can imagine the discussions that we're having at the moment, like, on that subject. But that's a topic for a different podcast, that's it.
If I can just come in very quickly on that, Matthew, apologies.
Sure.
We're talking about data quite a lot. One of the things that I've noticed with OEMs, and it's a cautionary tale really, is they will focus on their data and the data that they are generating within their organizations. One of the challenges there is that will automatically come with a level of bias. So what's really important is actually, when we're talking about data, we're talking about real world market data, how these products actually react and respond in the marketplace. And that's, you know, where an organization like Factum Research can be hugely helpful, because what we see is how these vehicles respond right across the repair spectre. So we've got access to that aggregated market data. If OEMs just focus on their own data, there is the risk of that bias coming into their development cycles.
That's great, Ben. Thank you very much, everyone, for that. Very, very interesting indeed. I wonder if you could just get your crystal balls out now and your forecasting heads. If we fast forward 5 years, what does a successful Western version of China speed actually look like, would you say? Is it simply about building vehicles faster, or will success be measured differently by how quickly companies can learn, adapt, and continuously improve?
Right, then let's start. There I'll take you up, Ben. In terms of learning cycles, right? I would measure it at exactly that, like in learning cycles, not build time, what I mentioned in the beginning, that like 2 versus 4 years building a new car. The speed of assembly is not the West problem. The speed of learning across the organizational boundaries is. So concretely, in 3 to 5 years, success looks like 4 things in my mind. Engineering changes propagating through the supplier base, not just your own company, in minutes, not days or weeks. Quality issues contained within a handful of vehicles rather than millions. Compliance and carbon reporting produced by a byproduct of normal operations, not a separate project. and data flowing, and this is the interesting part, between Chinese, North American, and European supply bases within each region's regulatory framework without rebuilding the infrastructure every single time. So just stick with that point for a second, right? Like if you were to task today Microsoft to build out a, let's say, automotive supplier infrastructure in China, no way, right? Same thing if you'd ask Huawei to do the same thing in North America. So there has to be, let's say, a little bit of a regional like specificity for that. And that's the last point where I'd caution against simply copying China. The Chinese model is optimized for domestic flow. It sits on a very different data governance regime. The personal information protection law, so people, the data security law, the cybersecurity law, and cross-border movement is significantly more restricted, particularly for data class as important, in quotation marks. At greater vertical integration, geographic clustering, and industrial policy coordination platform development, and a different stage gate and risk and recall posture. Western OEMs cannot vertically integrate their way to China speed, right? We can't, like, in the end, make a supplier base of 5,000 tier ones into, let's say, 500 tier ones in a stack of a year. And they should not dismantle the IP and competition boundaries that defines this industry. What does translate is the digital architecture, the shared standards, the multi-tier visibility, federated trust, and common semantic models. And it now works across regimes. What we've tried and let's say built over the past 2 years together with the Chinese Association of Automotive Manufacturers and the VDA, so the German Automotive Association in China, we've announced a first trusted cross-border automotive data ecosystem. Very hard to speak out loud, but linking Europe and China in terms of, let's say, how data flows in a trusted mechanism between Europe and China and operated inside China by a dedicated local operating partner. Same thing in Europe, all within secure, sovereign exchange under both EU and Chinese requirements. It took a lot of time to align that on both the regulatory side, the technical side, the language barriers, and so on and so forth. But in the end, this is something that allows us to, let's say, get the focus of the OEMs, like also in the Western world, a bit further away from these issues that could be solved with like a simple, let's say, I'm exaggerating a bit, right? But an architecture decision rather than like, let's say, let's solve each individual problem, each individual data flow ourselves. So to make it very concrete, and then I'll stop, Matthew, sorry. The battery passport is one of our fundamental use cases. Battery passport operational in 17th of February 2027. Every OEM that sells a car in Europe has to produce data from their supply chain. 80% for the batteries that are coming and battery cells from China directly, right? That can be generated once from real supply chain data and is accepted on both sides and border at the same time. But without that shared trusted infrastructure, a company in China has to file a cross-border transfer application that can take up to 5 months, and it includes, let's say, for the European clients with no guarantee of approval. That is the difference between infrastructure that you can rely on, that you can base your operations on, and paperwork in the end.
That's great. Thank you very much, Hanno. Ben, Isaac, any thoughts around that?
I guess for me, a slightly kind of different take on the answer.
Sure.
To me, in terms of where do they need to be in 5 years' time, and it comes back to the first answer I go to the question. It's about understanding the marketplace, and to be successful, they actually have to understand that market, and that market is changing. It's moving massively, and the desire for new product and new product speed is changing at a pace. We hear the term software-defined vehicles a lot. I don't like the term software-defined because all of these vehicles are still hardware-defined, but they're software-enabled, which is fundamentally changing the way that you can deploy your product in a marketplace. So again, if we stick to that habit that we have today, which is develop a vehicle, stick with that hardware platform for 7 years with a midlife update on 3.5 years, have a fixed cost of ownership that we're based on somebody chucking a huge amount of capex up front, that's going to be challenged in 5 years' time. I don't think that business model is going to work. So those Western OEMs need to move to a position where they're really focused on total cost of ownership. They're really focused on that annualized total cost of ownership. What does that look like? How do they push that through? How do they use the real world data on an annual basis on any product to ensure that that product remains competitive? What does that mean in terms of the risk of that vehicle in the marketplace? How can they understand how they can change the risk profiles of those vehicles through that life cycle? If we look at insurance as an example, insurance can be up to 25% of the cost of a vehicle through its life. So if you can take 3, 4, 5% off your insurance cost on a yearly basis, you're significantly affecting the total cost of ownership. So that ability to use the software-enabled vehicle to change the cost profile of that vehicle through life, I think is where you're going to gain an advantage. If you stick to the way of that's going to have to wait to the midlife update, or that's going to have to wait to a new platform, that's where Western OEMs are going to struggle.
Super. Thank you. Thank you very much, Isaac. What any thoughts around from you, from your
Yeah. So I mean, Hanno took a very kind of macro view of, how international collaboration and data flows across borders. Ben's just talked about kind of more at the like product level, what changes we might see over the next 5 years. I'll go even more zoomed in, seeing as we're going length scales down, to think a little bit about what my company Polaron works on, which is materials and the kind of science and material science of what goes inside the product. I think that if I look forward like 5 years, the thing that I hope to see is that some of the most kind of manual and trial and error and not data-driven processes currently happening today in the material science and in the kind of like engineering side of the product development, I think that's where I hope in 5 years that this is a much more data-driven, model-driven kind of process. I think that has a huge potential to accelerate the like Ben's been talking about, better consumer outcomes. And I think that we've talked about how technology isn't the barrier, like adoption, cultural change, organizational behaviors, that's the barrier. I think that what I see is that the technology isn't the barrier, but it's not being adopted fast enough and it's not being leveraged well enough because of all of the other things. And I think if we were to see that adoption, that the pace will be frightening. And I think that is something that in the West, we have some incredible advantages. We have some incredible assets in terms of engineering know-how, in terms of scientific output, and being able to put that into practice by faster adoption, easier adoption, lower friction adoption of a lot of this technology. I think that we'll see some very exciting things. And I think everything that Ben and Hanno said is like a large part of that, but it does trickle all the way down into actually designing new materials that can fundamentally change the behavior of the system. I think that it's exciting to see every kind of length scale, potentially transformed by this.
Thank you very much indeed, Isaac. Just before we wrap up, if I may, I'd like to take one takeaway from each of you. If you could recommend just one capability that automotive leaders should invest in over the next 2 years, what would it be and why would you say? Isaac, because you went last, would you like to start with this one?
Yeah, sure. I think probably my strongest recommendation, not so much necessarily kind of technological capability, but it would be that I think we've mentioned the kind of hierarchical structure of Western OEMs and how that can add a lot of friction to the way that decisions are made about what to adopt and how fast to adopt things. I would say that giving ownership to people close to the problem, to give them the room to experiment and iterate, and building this kind of like risk mindset around a disruptive technology, that would be the main thing that I would see. And I think that this is, if we're going to compete, it will be through moving faster around these things.
That's great. Thank you. Ben, can I bring you in at this point?
Yeah.
Thank you.
I think for me, I think one of the challenges that we've seen over the past 15, 20 years is OEMs have become very, very focused on regulation. And by focusing on regulation, they've become quite focused on what I would call tick box engineering. So engineers really have been given a solution envelope that they have to fit within. And they're no longer really thinking and trying to understand what the solution needs to be because the regulators have given them the solution. So they're in a very, very tight bracket. So my advice would be actually to invest in engineering, to invest in teams that can really think like engineers, think fast, fail fast, learn fast, bring in that closed loop learning so they really understand what's the data I need to look at, what's the market problem I'm trying to fix, and get back to what I call, old-fashioned engineering, really understanding what the problem is, how do we create that solution. Too many OEMs now have become so focused on just ticking the boxes. Have I ticked the boxes? Have I got the zero emissions? Have I got this? Have I got this? Absolutely, we have to consider those. We have to be working in a world of regulation. But actually, come outside of that, I think the point you made there, Isaac, is absolutely brilliant. You're giving ownership to those people, get the ownership at the right level, let them understand the problem and let them engineer solutions to those problems. Within that data environment, within a closed loop learning system, we can then do that at speed with the data flowing through the organization and the right people at the right level making the right decisions.
Thank you. Thank you very much indeed. Hanno, would you like to have the last word on this? One final
I'll try.
takeaway.
No pressure. You asked for one capability, right? And this might seem repetitive and boring, but like for me, it's really the ability to exchange data with any partner in your value chain on common standards without a bilateral integration project each time.
Sure.
Not another internal data lake, not another AI pilot. Interoperability in the end, because everything else we discussed on this panel today depends on it. AI is only as good as the data it can reach. And most of the data your engineers need sits inside someone else's company, not your own. So the last thing I would add is like I'd frame it as a when, not a whether, right? The infrastructure exists today. Regulation is basically making it unavoidable in a lot of the cases, and participation is becoming, at least in Europe, from our perspective, a condition of doing business. Like that you'll see hopefully expand over the next couple of years. So in the end, that capability will make, even though it might sound boring in like a direct conversation, right? It will make the biggest difference for anything data related over the next couple of years.
Thank you very much indeed. Not at all boring, all very, very interesting. Thank you very much, everyone, for joining us today. That's pretty much all we have time for this episode from Mobility Global. And thank you to everyone who listened. If you found this conversation useful, please do follow us on LinkedIn for more insights from across the supplier ecosystem. And keep an eye out for future episodes exploring the technologies and trends shaping the future of mobility. Bye for now.